So there's your answer there. Please, in pre-cal, don't use decimals. We don't want to see decimals. We want to see fractions. Now for a super piggy example. This one's tricky. Again, ignore that multiple choice. Try it on your own. This one is tricky. So you definitely want to hear me going over this one with you. Okay, so again, what we've got, pause your video if you haven't already, try it, then come back. The answer choice on this one does turn out to be D. If you could get that and support it with work, you don't need to watch the rest of this video. But I think most of you probably do need to watch this video. So again, we're taking a square root, so we know that what's underneath the square root symbol, x squared minus 16, cannot be negative. So our domain is only going to be values of x that make this positive or equal to 0, greater than or equal to 0. So add 16 to both sides, and we end up with that. To get x, we need to take the square root. Now, when you take a square root, don't forget you're going to get a positive and a negative value, and that really messes up with this greater than or equal to. You can't look at it that simply. You can't say it's greater than positive 4 and it's greater than negative 4. It doesn't work like that at all. All we can tell from this is something special is going to happen at x is positive 4 and x is negative 4, and changes will happen. Why has my computer gone off? Oh, I'm not using my computer. I'm on my iPad. It doesn't matter. Sorry. So let's have a look at that. We've got to this point here, and what we've managed to establish is we can expect the domain to change in some special way around these values. So what we're going to, I don't want you to try and memorize or guess how to solve this. You've got to find a way to actually work this out that involves thinking. Please don't just try and memorize silly rules, try and understand your math. So the first thing I'm going to do is draw a number line from negative infinity to positive infinity and put those two values on. I know from what I can see here that they're going to be included, so they're going to be solid blobs, and I can see that those two values in the middle have actually divided this number line into, let's see if I can find it, somewhere around here I've got some lines I should pick up. Okay, they've all gone. Never mind. No, they are there. I know they're there. Never mind. I'll draw them in. It's dividing the number line into 3 intervals. Now what you want to do is look at each interval and see, does it make that condition in each interval true? So choose any value of x you like in each interval and test it. For instance, if I was in this interval from 4 across to, if I was in this interval here, choose an easy number of x. You could choose 5, you could choose 10, you could choose 99,999. Just choose an easy value. I'm going to choose, oh, I had something hidden there. It's I did up here. I would suggest choosing 5 or 10 in that interval. I'm going to choose 5. So think about it. If x was equal to 5, 5 squared is 25, and is 25 greater than 16? Yes, it is. So in this interval, this condition here is true, so that will give me part of the domain. Don't know why that disappeared. So let's look between negative 4 and 4. What value of x would you choose in that value, in that region? Personally, I would choose either x equals 0 or x equals 1. There you go. Choose either of them. Let's just use x equals 0 and think about it. If x was equal to 0, x squared equals 0 squared, which is 0. And is it true that 0 is greater than or equal to 16? No, that's not true. I can't even write the word false. So in this interval of the domain, no values of x are going to work. If you think about them, put them back in all the way back up here. If you put 0 in here, why is that not good? Why is that not a value we can use in our domain? Because can you take the square root of negative 16? You'd get a complex answer, and that's not something we're going to graph on a graph of a function. Functions have to be something that gives you something that's real and defined. If you chose negative 3, which would go here on the number line, negative 3 squared would give you 9 here. 9 minus 16 is negative 7. And again, you'd be getting a complex number as your answer. So none of the values of x in this region over this interval will work. So let's have a look at this interval over here. Choose a value. You could choose x is negative 5, x is negative 10, anything you like. I'm going to use x as negative 5 and think about that. If x was equal to negative 5, we would be about there. That's a value in this interval. Negative 5 squared equals positive 25. And is it true that 25 is greater than or equal to 16? Yes, it is. So this is a good part of our domain as well. So those highlighted areas show us what parts of the domain are good, and your answer is here. From negative infinity to negative 4, this is good, and from 4 to positive infinity. And your negative 4 and your positive 4 were included in your domain. Okay, so stop your video here and we'll start a second video in a second.